Hello guys, today's day problem is search pattern, and in this problem we'll be given two strings. Uh, Name of first string is text, it is txt, and name of other string is fact, which is a pattern. And the first thing we need to do is we need to find all occurrences of string pattern in text string. We need to mind it is string, not it is not sequence. Okay, so and we need to use one base indexing. And we need to find all initial index of occurrences. Like here we do have geek, right? The first we can find this occurrence here, geek, and we can also find it here. So the first occurrence happens at index one. Like we need to take one base in the indexing, so it happens at one, and the second occurrence starts at index nine. So the output will be one and nine. If we do not find any occurrence, we can simply return empty array. Okay. So the prerequisite for this problem is uh, one needs to know KMP algorithm. If you do not know, I can explain to you as well. So the thought process is that first we need to add pattern string. Like we need to merge pattern string, text string, and we need to keep a special character in between. And I can explain why at the end of the video. You can understand why we have added extra character here. So this is the given string. Um, Let we will maintain a prefix array. Prefix array states like how many like maximum number of characters we could match with the prefix, right? So let us start the solution. Um, Before g we do not have any characters, right? So initially the prefix value of g will be 0, and at e uh, we were able to match 0 characters previously, right? So initially the value of j will be 0, right? And now we can compare if A matches with calculate index J. At J we at index 0 we do have G, and E does not match G, right? So since E is not equal to G, J remains 0 and prefix will be 0. And here as well, uh, we were able to match 0 number of characters initially, so the value of J will be 0. And at character index 0 is G, and G does not match with E, right? So the prefix remains 0 here as well. At K, let us see. We were able to match 0 number of flags. So initially the value of j will be 0, and character at index 0 is z, and it does not match g, so it will be 0 as well. It hash as well. Hash is the special character uh, we have added. So initially we were able to match 0 characters, right? And since hash does not match with g, like first character at index j, I mean 0 is g, and hash does not match with g, so the prefix remains 0. Let us come to G now. Previously, we were able to match 0 characters, I mean no characters also. So value of J will be 0. The character at index J, I mean 0 is G, right? Uh, and G matches with G. So we increment J, and prefix states that we were able to match one character in the prefix. The first character is G, and we can match G with G. So uh, the maximum length we can match is 1 right now. And let us come to E right now. And we were previously able to match one character, right? So the value of j will be 1, and let us match this e with character index j. At index 1 we do have e, here also we have e, so we were able to match it, so we can increment j, and now the prefix becomes 2. uh, Here as well, previously we could match two characters, right? So the value of j will be 2 here, and the character at index j, I mean 2, is also e, and here also we have e, so we can increment j, and the value of prefix here will be 3, right? So um, let us move to k. Previously we were able to match three characters, right? The value of j will be 3, and then uh, the character at index j, I mean 3, is k, and k matches k, so here also we can increment j, and now we have prefix as 4. Remember the value of given pattern, I mean the length of given pattern string geek has length 4, and here we were able to match four characters, right? So this means that we have found out an occurrence that ends at index 8, right? We need to return starting index actually, but let us store it first, right? So the ending index of first occurrence is at N, right? Okay, fine. Then let us go to S now. Previously, we were able to match four characters, right? And so the value of J will be. So let us match this S with character at index 4. The character at index 4 is as, and S cannot match as well, right? So in this case, we need to update J since we were unable to match the first five characters, right? We were able to match only four characters previously, but we could not match the fifth character. So let us see if we can match at least three characters. So we'll update the value of J with prefix of J minus 1. I mean, which is prefix of J is currently 4, it will become 3, right? Uh, the value at prefix 3 is 0, right? So we were unable to match any characters. And after updating J, let us check if we can at least match the first character, like the value of J is 0. At jth index, we do have G, and G does not match with S, right? So the value of prefix here will be 0 again. So again, previously we were not able, I mean, we were not able to match any characters, right? So the value of J will be 0 initially, and character at jth index, I mean 0 is G, and G does not match with F, right? So here also we have prefix as 0, and same goes for O as well. We were unable to match any characters, right? So the value of J will be 0, and character at jth index is G, and J does not match with O. So here also prefix means 0. Same goes for R as well. Uh, Initially we were not unable to match anything, right? Here we have 0, and the first character is G, but here we have R, so prefix means 0. And let us come to G again. Previously, we were unable to match any characters. We have 0 here as prefix of previous index. So let us check what is at index J. I mean index 0, we have G, and here also we have G. So we can increment J, and now J becomes, I mean prefix becomes 1, right? And previously we were able to match one character, right? So here the value initial value of J will be 1, and let us check what is at index J. At index J we have E, and here also we have E. So we are able to match it. Uh, we can increment J, and now we have prefix 2. Similarly, now we have E. Uh, After having E, we were able to match two characters previously, right? So we can make J as 2, and let us check what is at index 2. At index 2 we have E, and here also we have E. So we can increment J, and since we have incremented J, the value will be 3. Okay, so coming to K, previously we were able to match three characters, right? The value of J will be 3, and let us check what is at index J. I mean index 3, we have K. Here also we have K, right? Here also we have K, so we can increment J, and now uh, the prefix will become 4. uh, Again we can observe the same. We have GEK here with we were able to match four characters. Here also we have GEK. We were able to have four characters, which is the length of pattern string. Also, we can store this as well. The I mean the ending index of another occurrence is 16 in this case. Okay, so yeah, we can continue with that. Uh, Before us, we could match four. We were able to match four characters, right? So the value of J will be 4, and at fourth index, we have hash, but hash does not match with S, right? So we can update J with prefix of J minus 1, which is prefix of 3, which is 0, right? We have prefix of 3 is 0, so we can take this as 0, right? So yeah, this marks the end of string. Like now we have got two ending indexes of strings. Now, the only part remaining is that we need to perform subtraction operations, right? The matching indexes were 8 and 16, right? You can observe we have added pattern and a special character before the original string, right? So we need to remove this these characters. So uh, the length of pattern was 4 and the special character added was 5. I mean it was the length one. So we need to remove 5 characters, right? So this index becomes 3 right now. And here as we remove 5, the starting index becomes 11. So these are the ending indexes, right? Let us see. This was at index 3. It is the ending index of this pattern geek, and it is at 11. It is ending of this occurrence of geek, right? So the starting index is 3 minus the length of pattern was 4 plus 1, which adds up to 0. And here also, and we need to reduce length of pattern and add up. So it becomes 8, right? So this is this is a solution if we consider zero based indexing, right? The answer should be 0 and 8, but we were told that we need to use one based indexing. That's when we increment it with 1 to make it one based indexing. So the answer becomes 1 and 9. So let us see how the code would work. So initially we have merged both the strings and we have kept the special character in the middle, right? So the resultant string will be uh, pattern concatenated with you can take any special character and like I'm going to take dollar in this case and then you can increment. I mean we can merge text as well. So let us maintain the prefix. It will be of length of resultant string and we can initialize it with 0, right? So we can iterate for the first character. The prefix will always be with 0 because we do not have any characters in front of it, right? So we can start iterating from 1 right away. We can go up to resultant length, right? Then, so initially the value of j will be number of characters. I mean, max and of characters we were able to repeat it from. I mean, with this prefix I minus 1. Uh, right now we are going to check if uh, j is greater than 0, and in this case we are seeing that at s the value of j is 4, but the pattern index is I mean cat rate index 4 is as we are unable to match it, right? So while we are unable to match it, we can reduce j to prefix j minus 1. So that we are going to do that thing. Uh, while resultant like cat index j is not equals to factor at I. What we are going to do is that we are upgrading j with prefix j minus 1 root. So at the end, uh, we can get the j, and after getting the j, we are matching. Like in this case, we can see as well if we are able to match index j and the correct current character, we are incrementing the j, right? So we can do it if uh, we can match j with current character. That means that we can increment j and the prefix I will be j. And since we can initially store the ending indexes as well, so we can take an array in integer array to store the indexes. I mean, if we were able to match all these characters, then the prefix will be 4, right? Because we are able to match 4 characters. If uh, prefix I is same as length of pattern, right? That's when we can store the index of, I mean, we can store the ending index initially, right? So we are going to store I, right? Uh, and after the entire thing, what we are going to do is that if uh, there there is no occurrences, there is no occurrences, like though so the size of indexes will be 0. So we can simply return an empty string, or we can return indexes as well. There is no need to modification. Otherwise, as I said at the last, we need to modify this. We need to remove pattern length plus one, like those many characters from the string. So let me iterate the string. So the, the updated value will be minus. We have added pattern length, this geek in front of entire string, right? So we can remove those many characters, and we can also remove a special character, right? So the updated value of indexes right now, in this case, we'll get this thing 3 and 11, and then together, I mean, right now, what we have got is we have got the ending index, right? We need to get the starting index. So we need to update it again. To get it, we need to decrease it with the length of pattern length, right? And for that, and we need to increment 1. So right now, we can get we can get 0 based indexing as an answer. Like we can get 0 and 8 initially. So let us check it. Okay, I'm sorry. It should be indexes, right? Yeah. So right now, we will get answer in 0 based indexing. So we should increment by 1. So as we can see, what we got was 0 based indexing, as we have done it here. And at the end, we should increment it by 1 to make it 1 based indexing, right? So at the end, I can simply increment with 1. Right now, this will work. Let us uh, analyze the time complexity of this solution, right? So just run it. Turns on all the cases. The time complexity of the solution will be order of n plus m, if where n is the length of the string text and m is the length of string pad, and